friends, today I will discuss the formation of the Tieset matrix. Here, let us take a problem. Find Tieset matrix for the following graph. So this graph is nothing but a oriented graph in which we find the four nodes. This is one node which is represented by one dot here. Similarly, this is second node represented by 2, and this is another dot, that is node 3. This is another dot, this is fourth node, and the branches are A between 1 and 2 nodes, between 1 and 3 branch B, between 1 and 4 branch C, between 2 and 3 branch D, between 3 and 4 branch E, between 2 and 4 branch F, and they have the current directions like this, and this direction can be chosen as per the wish. So for getting the Tieset matrix, so we should know what are the twigs. Twigs means the thick lines of the tree for a given graph. For getting that, we take the number of nodes and subtract by 1. So here the number of nodes are 4. So that is capital N, minus 1, that is 4 minus 1, that is nothing but 3. Then total number of links, which is required to know the number of Tiesets. Number of Tiesets is equal to the number of links for a given graph. So number of links can be obtained by taking total branches of the graph minus the total twigs of the graph. So here the twigs of the graph is nothing but 3. So total number of branches are nothing but 6. So we can write b minus t or b minus n minus 1. So n minus 1 calculated already. So that is nothing but small t. So here b is total branches a, b, c, d, e, f, 6 branches, minus t means number of twigs, that is 3. So 6 minus 3 or 6 minus 4 minus 1 is equal to 3. So the total number of Tiesets we get here are totally 3. Now Tieset means it will have only one link and rest of the elements are twigs, they are thick lines, whereas links are shown by dotted lines. And we also assume the loop current direction as per the wish. So for Tieset 1, we get one link like this, that is between 1, 2, 3. We have the 3 elements. Out of that, A element will be treated as a link, whereas the other elements are thick lines, or they are called twigs. And the assumed current direction is I1, flowing in the clockwise direction. Similarly, Tieset 2 is nothing but it is the loop formed by 4, 3, 1, 4 nodes, and elements are B, C, E, and the assumed current direction for the loop is I2 in the clockwise direction. Similarly, Tieset 3 is obtained using the F, D, E elements, whereas D and E are twigs, thick lines, whereas F line is a link shown by dotted line. Here we assume the loop current as I3 like this. So we calculated the number of Tiesets that we get for the given graph is nothing but total number of branches minus total number of twigs. So that is 6 minus 3, that is 3. So here we are getting 3 Tiesets, that is there are 3 links. This is 1, this is 1, this is 1. So remember here, a tieset means there is only one link present. So now this tieset is nothing but the relation between the loop currents and the branch currents. Branch currents are already assigned and the loop currents are assumed here like I1, I2, I3. So to get the relation between the loop currents and the branch currents, first we have to assign the what are the branches connected to the tieset 1, and similarly what are the branches connected to tieset 2, similarly what are the branches connected to tieset 3, and the disconnected branches are for each tieset also we should calculate. So when we look at the tieset 3, the number of elements or branches connected to this are only 3, that is DEF, whereas the unconnected elements are ABC. Similarly, second set is nothing but BCE are the elements connected, whereas the other elements are disconnected elements, right? Make the table like this. Similarly, first tie set, the elements connected are ADB with the loop 1, that is ABD. Then unconnected elements are CEF. For all disconnected branches to the corresponding loop, treat them their values as 0 in the matrix. So let us write the loop equation, or it is the matrix. This is called the Tieset matrix. So loop currents on the column and branch currents, loop currents are like this I1, I2, I3, they are rows, whereas branch currents are columns. So for the first tie set, the elements connected are 1, A, B and D. AB direction current is same as the assumed loop current, whereas the D branch current is opposite to the assumed current direction, so we get minus sign here, and rest of the elements are 0. Similarly, for second tie set, the currents B and C will get the positive sign, whereas E will get the negative sign. So plus 1 for B, for C plus 1, whereas for E it is minus 1. For E it is minus 1, for B and C it is plus 1. And rest of the elements are disconnected, so put 0 here. Similarly, we have seen the last cut set, that is tie set, that is tie set 3, whose loop current is I3 and the elements connected are DEF, whereas F is opposite to the direction of the assumed current I3, so we get here minus sign. So whereas D and E elements currents and the I3 direction are one and the same, so we get plus 1 here. So this is the Tieset matrix for the given graph. Similarly, let us take another problem. Find the Tieset matrix for the following graph. So this is the given graph with the 4 nodes. This is 1, 2, 3, 4. So the first step is make this graph oriented graph. That is, assume the current direction in each branch like this. Here it is A and B here, C here, E here, F is here, D here. For each branch there is a name for it. Similarly, there is a current direction for this. After this, find out what are the number of tie sets possible. So that we get by knowing the total number of branches. So here the total number of branches are 6. And from that subtract the total number of twigs possible. So here twigs are nothing but total number of nodes minus 1. So number of nodes are here are totally 4. So 4 minus 1 is the twigs, that is represented by small t, whereas the total branches are 6. This is 1, 2, 3, 4, 5, 6. So this many Tiesets we get here. So to get the Tieset matrix, so first find out the Tiesets for this graph. So for getting the Tieset matrix, so first find out the Tieset graphs. So in each Tieset there will be only one link, whereas the other elements are twigs. That is here B and C are twigs, means thick lines, whereas the A is link. Similarly, Tieset 2, B and E are twigs, whereas D is link. Similarly, Tieset 3, E and C are twigs and F is link. And then assume the current direction. So for Tieset 1, the direction of the current is clockwise and we call that as I1. Similarly, for Tieset 2, the current direction is clockwise direction, we call it I2. And similarly, Tieset 3, the current direction is clockwise direction and it is I3. And this Tiesets are obtained only after getting the tree. So tree is nothing but a graph which connects all the nodes without forming any closed path. Look at this, 1, 4, 2, 3. All nodes are connected and the connecting lines we call as twigs and they are thick lines. So using this, we have to find out what is the Tieset 1, Tieset 2, Tieset 3. Each Tieset will have only one link like this. After knowing the Tiesets, so find out what are the branches connected to Tieset 1. Similarly, what are the branches connected to Tieset 2. Similarly, what are the branches connected to the Tieset 3. Similarly, also find out what are the branches not connected to the Tieset 1. So for Tieset 1, the branches connected are A, B, C, whereas the disconnected branches are D, E, F. Similarly, Tieset 2, the branches connected are B, D, E, and the branches disconnected are A, C, F. Similarly, Tieset 3, the branches connected are C, E, F, and the disconnected branches are A, B, D, like this. So once we know this, look at whether the branch current and loop currents are flowing in the same direction or opposite. If the current flowing in the branch is same as the loop current, then the sign we get is +1, whereas for other direction it will be minus. So if you look at the Tieset 1, the direction of I1 and the direction of branch A is same, so we get +1. So whereas direction of B and C, they are opposite to the I1 direction, so we get BC elements at -1, whereas the other elements are not connected to the loop 1, so put zeros here, that is DEF is nothing but zeros. Similarly, for loop 2, the elements connected, this is the Tieset 2, the loop current is I2 direction, B branch and E branch current direction, and also D branch direction is also one and the same. So B, D, E directions are same, so all will get the positive sign. So B, D, E, +1, +1, +1, and rest of the elements are not connected to the Tieset 2, so put zeros for those elements. Similarly, Tieset 3, here also the direction of I3 and the direction of branch C and direction of branch F are one and the same, whereas the direction of E is opposite to the I3. So direction of E element will get the -1 sign here. So whereas C and F will get the positive sign, and rest of the elements are not connected, so put elements as 0 like this. So This is the Tieset matrix for the given graph. So we have seen how to obtain the Tieset matrix using the two problems, numerical problems. To get the Tieset matrix, we should know the oriented graph, and from that we should get the tree, and from that tree we should get the Tiesets possible. The Tiesets possible is equal to the number of links. So that links we obtain using the total branches minus the number of twigs, that is n minus 1.